Yes.
Our next talk is by Jackie Kagey, who is going to be speaking to us about lessons learned from Space Shuttle and ISS EVA operations.
Thank you very much. Can you hear me?
Can hear you loud and clear.
Yes.
Great. So as he said, hi, I'm Jackie Kagey. I'm an EVA officer, and we'll discuss information and brief lessons learned from ISS and Shuttle EVA operations across my 20 years in flight control. Next slide. The Space Shuttle and the International Space Station Flight Control Team strategies, function, and setup were based on predecessor NASA missions, including Apollo. The Flight Operations Directorate, FOD, formerly known as MOD, uses lessons learned and best practices after each mission in EVA series to continually refine the flight control team. Over the years, we've integrated international partners, payload specialists, and hardware owners as the vehicle and stakeholders expanded. The goal of today's presentation is to describe how EVA successfully and efficiently operates within the shuttle and station teams, and also to introduce FOD's 7 essential qualities of professional excellence. Next slide. The U.S. Flight Control Team provides real-time operations expertise on the U.S. segment and is led out of the Mission Control Houston. This team is led by Houston Flight, who has overall responsibility for mission integration, execution, and the authority to make real-time decisions to ensure the safety of the crew. ISS and success of the mission. So Houston Flight is also responsible for providing recommendations to the IMMT, or the ISS Mission Management Team, including concurrence of international partners when operating outside of the flight rules. I've listed the front room members of Mission Control Houston, and in each discipline may have multiple certified black room flight controllers. Additional members of the U.S. control team includes the ISS MER, led by MER Manager, IMC, who's our program representation, POC for payloads, and the HOSC, which is the Huntsville Support Center. Partners to the U.S. Flight Control Team include our international partners and our industry vehicle partners. Although ISS and Space Shuttle Flight Control Teams had some differences, EVA and how it operates remained relatively the same. EVA works under the lead flight director of the controlling vehicle and integrates across the programs. In this, you can see one of our essential qualities of FOD, teamwork, respecting and using the abilities of others, realizing that we work toward a common goal, for success depends on the efforts of all. Next slide. This slide is to give you a visual representation of the EVA during real-time ops. Not all disciplines are listed, and the structure of outside teams is not shown. What I want to show you is that EVA reports directly to the flight director. We work side by side with ground IV and Capcom, surgeon, robo, and vehicle experts. EVA currently has 2 certified backroom positions, EVA Task, who is primed for timeline, tools, and procedures WIWAR EVA, and EVA Systems, who is primed for the EMU and its interfaces to ISS. Those positions work with the other flight control backrooms, hardware experts, whether in the MER, DoD, IPs, or payloads. This direct working level communication is integral to the success and efficiency we have during EVAs. For example, on the past mission, we worked hardware built by JAXA. During the EVA, JAXA EVA coordinated directly with EVA Task so that decisions were reached quickly and were communicated effectively to the flight director. If there was a time where opinions differed, each discipline had their own path to further work the issue. JAXA EVA could inform J-Flight, and then J-Flight and Houston Flight could further discuss. This brings the next essential quality to light: discipline. Being able to follow as well as lead, knowing that we must master ourselves before we can master the task. Next slide. The FOD EVA team is responsible for crew and flight controller training on all EVA hardware. Hardware owners and subject matter experts are integral to the process. We conduct many types of training events in which we request the SMEs participate, included suited pool runs, 1G reviews, and offloaded events. Nominally, reviews on flight hardware are conducted by the hardware owner, with the FOD leading the relative training aspects. Another training item is EVAT, which is an EVA assessment team comprised of FOD, engineering, hardware SMEs, safety, and others. This team reviews the EVA procedures and crew training to verify all constraints are followed and operations occur effectively and safely to both crew and hardware. Training builds our next essential quality, confidence. Believing in ourselves as well as others, knowing that we must master fear and hesitation before we can succeed. Next slide. So pre-mission processes are also very important. Agency and programs will define EVA tasks and objectives, giving us priorities to work to. FOD EVA works with the hardware experts, taking drawings and ConOps to develop into EVA procedures and training documents. Building of training mock-ups and viewing of flight and test articles are included in this timeframe. Early EVA planning can be started multiple years out and lasts through the month before the EVA. During this timeframe, we receive hardware owner deliverables, host training events, participate in JOPs or joint operations panels, integrating inputs from the entire team in the shaping of our products. Much of this information is currently hosted on an internal NASA wiki page, and we have open forward work to determine how we would interface with teams outside the NASA domain. Another pre-flight event is CEIT, Crew Equipment Interface Test, which allows the crew members in FOD EVA hands-on with the flight hardware just before launch. The overall process is similar for contingency and unplanned EVAs, but all within a shortened time frame. The ISS record is 36 hours from time of failure to performing US EVA 21. After that, around a month out, products are normally dropped into the flight note system, which allows parties to assign approval. Ideally, comments and changes are caught well before that, but can happen at this point in time. This process helps all parties work to the FOD essential quality of competence, there being no substitute for total preparation and complete dedication, for flight will not tolerate the careless or indifferent. Next slide. During real-time operations, the ground IV is in direct communication with the EV crew, and Capcom is prime with the IV crew. If operations are nominal, the flight control team is in receive mode. We acknowledge the crew's progress and expertise as they advance through the EVA procedures. During off-nominal operations, the flight control team is ready to immediately direct the crew. For this, we use cuff checklist pages for suit issues, a task crib sheet with predetermined responses agreed to by both FOD and the hardware experts, and direct communication between the hardware experts and the EVA console to discuss workarounds not previously identified. Team integration ahead of EVAs normally works out disagreements, giving us a good working relationship for real-time support. Real-time decisions showcase the flight control team quality responsibility, realizing that it cannot be shifted to others, for it belongs to us. We must answer for what we do or fail to do. Next slide. A good example from the Space Shuttle program of an integrated team working an unexpected issue quickly and competently is EVA-3 on STS-117, the Thermal Protection System Blanket Repair. Orbiter imagery reviews identified a peeled back blanket, and analysis determined a repair was needed. The ground team developed techniques to repair what was using what was on board shuttle, including a surgical staple gun, which is not a normal EVA tool. The compressed and cohesive work by those on the ground led to a successful EVA repair and safe shuttle return. This highlights one of the foundations of FOD, to always be aware that suddenly and unexpectedly we may find ourselves in a role where our performance has ultimate consequences. Next slide. A more recent example on station was during US EVA 41, where one of 4 shields was lost overboard after it floated away from the crew during the EVA. This shield was important to both MMOD and thermal protection for ISS and for future element integration. During the EVA and the EVA backroom, flight controllers, more hardware and tool experts, safety, and others developed a workaround. Because of the quick work of the joint ground team, a solution was found during that same EVA using hardware already outside to ensure no additional risk to ISS. This emphasizes the importance of toughness, taking a stand when we must, and to try again and again, even if it means following a more difficult path. Next slide. EVA operations has increased risk and costs above nominal spaceflight. Therefore, the team needs to keep deliberations, decisions, and communication prompt and concise. Speed is enabled by pre-EVA preparedness and hardware expertise. MEs are in direct communication with the EVA team throughout the EVA process, training, and in real time. They have a pre-approved crib sheet to enable workarounds that do not require real-time discussions. And this crib sheet is developed by the team considering all the what-if scenarios that they can imagine. EVAs are currently planned to the minute, so any delays will omit the completion of other tasks. We do acknowledge in the future Artemis planning will be different, but being ready on the ground and on orbit for get-ahead tasks to enable more tasks to be completed if the crew is ahead or determine that the planned tasks are unachievable. This keeps efficiency high without adding additional risk. This stresses our last essential quality of professional excellence, which is diligence. Being always attentive to the dangers of flight, never accepting success as a substitute for rigor in everything we do. And my last slide. Okay, so in summary, Shuttle and ISS EVA Flight Control Team operations are a successful example for future programs to model. Our key takeaway notes are clear direction and agreement on controlling authority is needed, having integrated meetings and training events, support plans such that working level personnel have direct access to each other, and documented processes for flight products. And I think that's all I have. Thank you.
Excellent. Thank you very much for that insight from mission operations.